All right. All right, so today we're going to look at something maybe a little bit new to you, but composite functions. Have we heard of a composite function? Or even seen the word composite function? Okay. Well, let me kind of explain it. So a composite function. Composite function. Let me give you this example, and just to make sure we know how to plug things in before we look at a composite function. Let's say I give you a function, f of x. Okay, and we've seen a function written like this, f of x. Sometimes it's just y, which is the same thing, but this is just f of x. It's just another way to write, y equals. So f of x equals, let's say we have a parabola, y equals x squared, or f of x equals x squared. Okay, before I do this composite thing, just this notation. If I ask, hey, what is f of 3? Well, what am I asking you to do? Wherever you see an x, plug in 3 in its spot. That's all it means. So that's going to be 3 squared. Right? And then, so f of 3 is 3 squared, which is what? 9. Okay, and that's f of 3. If I said f of 7, you plug in 7 there, it'd be 49. F of negative 2 would be whatever, 4, right? Okay, if I say f of x plus 7, well, here's our f of x. Well, same thing, right? So wherever you see an x, what do we substitute in there? X plus 7. So f of x plus 7 is, parentheses, but x plus 7 squared. And then we'll leave it like that. We'll leave it like that. We're not going to FOIL it. We'll just leave it like that. If I said f of x minus 4, real easy, right? Just wherever you see an x, put, so it's x squared, so x minus 4 squared. Okay. That's just what we're, as far as the notation of just a function, just plug it in. Wherever you see an x, plug it in. Okay, so let's look at a composite function example. And this is like your homework. So number 2. I'm going to give you f of x equals x squared. And let me give you another function, g of x, just a different function. G of x equals x minus 1. So I'm going to box that. So I'm giving you these two functions. All right, if I ask what is f of, and you could put like 3 in there, or you could put x plus 2, but I'm going to put f of g of x. Okay, no big difference. It's just f of something, what it just happens to be f of g of x. So the directions on your homework will say, well, write out what this is our composite function. Write out what the composite function will be. And then I think they're going to want you to just graph it. Graph f of g of x. Okay. Well, this is what we do. Kind of easy. F of g of x. So f of, hey, well, what's g of x? X minus 1. So just put x minus 1. So it's f of x minus 1. Okay, well, we just did these in that first example. Let's go back up here. Well, f of x minus 1, well, wherever you see it, this is in the f of x function. Wherever you see an x, what do we substitute in place of x? X minus 1. Okay, so this is x minus 1 squared. So f of x minus 1, wherever you see an x, put x minus 1 in. So it's x minus 1 squared. There it is. So this is what they want you to graph, this composite function. So this y equals this. Well, we just did a million of those. Okay, let's graph the parabola. Which way does it shift? 1 to the right. 1 to the right. Does it go up or down any? No. 1 to the right. There it is. There's our vertex. Shifted it 1 to the right. And let's just pick one more number. What do you want to plug in? This is 1. 2 is a good one. Right? If you pick x equals 2, what's y? 1, right? 2 minus 1 is 1. Squared is 1. Okay, so 2 comma 1. There you go. If we picked 3, let's just pick one more here just because. If we pick 3, What's y? 4. 3 minus 1 is 2, squared is 4. So 3 comma, it's a little up there, 2, 3, 4. There you go. So we can pick some on the other side, but we just know it's symmetrical. Actually, if I put 0, we're at 1. My graph is way off there, but there you go. Okay, so there's a composite function. Composite function. Okay, pretty easy if you kind of understand the concept. Just wherever you see an x, that's what you plug in. All right, so it's number 3. F of x, let's say it's 3x squared, and g of x equals, we'll do x plus 3. All right, so do the same thing. We're going to find, we'll do, f of g of x. F of g of x. And this is what a composite function is. Well, so in the f function, that's kind of your main function, the one on the outside there. That's your main function. So it's f of, well, f of what? X plus 3, because that's g of x, right? So I just substitute, there's my g of x. And okay, so in our f of x function, let's, wherever we see an x, what are we going to substitute in place of x? X plus 3. Okay, so this is, well, we have a 3 there on the outside. It's 3 times x squared. Okay, so it's 3 times something squared. Right? 3 times something squared. Well, what's the something that I plug in? X plus 3. X plus 3. And that's what we're going to graph. That's our composite function. Okay, so let's go and sketch that. All right, so this shifts how many to the left? 3 to the left. 1, 2, 3. Nothing up and down, so there it is. Let's pick a point. X, Y. Let's pick negative 2. We're at negative 3. So let's pick negative 2. And at negative 2, plug in for x. Negative 2 plus 3 is 1. Squared is 1 times 3 is 3. So negative 2, 1, 2, 3. There it is, your additional point. And there you go. There you go. That's it. Okay. Composite function, that made sense? Does that make sense? Okay. All right, let me do one with an absolute value here. I'm going to turn this over. Okay, so number 4. Okay, let's say g of x equals negative 3 absolute value of x plus 1. And f of x equals x minus 2. All right, so let's see. Let's find this composite function, g of f of x. G of f of x. So g is our main function. G is our main function. All right, well, so this is g of what? X minus 2. Just says, so x minus 2. Okay. So what do we do? Where do we put the x minus 2? Substitute it for x. In the g function, it says g. Okay, so this is negative 3 absolute value of something plus 1, well, absolute value of x minus 2. And I think we're pretty good at graphing these now. Right? So in place of the x, we put x minus 2. All right, so let's go ahead and sketch this. Okay, excellent review. So it shifts, how does it shift?
2 to the right, up 1.
2 to the right, up 1. 1, 2, up 1. There we go. Okay. And Laura, does this open up or down? Down. It opens down because of the -3. There you go. And then so Nate, so it opens down. Laura said, how do we figure out where, how, what? How do we figure out how to do that?
Oh, we use the 3 as a slope.
We use a 3 as a slope. Well, how do we use this 3 as a slope? What do?
We graph the next point using the slope, using rise over run.
Okay, rise over run. So we need to make that a fraction. Excellent. So let's just put a 1 under it. Okay, so it's down 3 over 1. All right, so down 1, 2, 3 over 1. Okay, there we go. Opens down. Got that. Down 3 over 1. There we go. And there's your little crooked absolute value graph. Easy as that. Easy as that. All right. Okay, does that make sense? Okay. Also on your homework, there's a problem like this. So it's not a composite, so kind of switching gears here. They want you to describe a translation. Describe this shift. So describe this translation. Translation. Okay, so 5A, they want you to graph f of x and g of x on the same grid, okay? And then B, describe the shift. Okay, describe the translation from f of x to g of x. Okay, so it's easy, just need to see it done once so you know what to do on the homework. So let me give you both. So f of x, I'll let you get caught up here. F of x equals x minus 2, absolute value, and then plus 1. G of x equals x plus 3, absolute value, then plus 3. Okay, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3. I don't know if we need anything down there. All right, so go and get caught up, and then I'll show. It's real easy. Just wanted to show you at least an example of one of these problems so you're not confused on the homework. Okay, so let's go ahead and plot f of x. All right, so if we plot f of x, and Anthony, how do we shift this graph? Right 2 up 1. So right 2 up 1. There it is. And then, Anthony, does this open up or down? Up. And how do we open it up? Good. There's no negative, so it opens up. What's the slope?
1.
There you go. It's 1. So up 1. So technically it's 1 over 1, right? So up 1 over 1. You could even go up 1, back 1. But there's our graph. Okay. And go and label it. This is f of x. That's f of x. Good. Good. And then, Tanner, how do we graph the g of x?
Left 3, up 3.
Good. Left 3, 1, 2, 3. Up 1, 2, 3. There it is. And this one opens up as well. It has a slope of 1, so up 1 over 1. Up 1 over 1, even back. So there's this v. Okay, label that g of x. It's exactly like your homework. Different equations, but this is what they want you to do. Graph both. So that's part A. We graphed them. Bingo. We can graph all these. We can graph any of these now, right? Okay, then B, describe the translation from f of x to g of x? Well, that's easy, just from this point to this point. Well, here's our description. So part B, it went, how many did it go this way? 5 to the left. So just go 5 left. And then it went up how much? 2? 1, 2. You kind of look right there in the equation too. And then up 2. And that's it. That's all they want. That's all they want. Okay, so graph both, label it, describe the shift. Okay. So I just want to make sure it's easy, but I just want to make sure you see it. And let me do one more. This is just a review, because I know it's on the homework, so I'll just put a review. So I want you to graph this equation. So let me, I guess I'll call this number 6. X minus 2y equals 8. So we want to graph this. There's other graphs on the review, but this one I know might not have looked at too close. So what is this? Is this a parabola, a V, line? It's a line. It's a line. We've got y equals, eventually just x to the first. So y equals mx plus b. So let's go ahead and put it y equals mx plus b. So we need to solve for y. So algebraically, how do we do that? What do we do? What do we need to do algebraically to get y by itself? What do we do first? Let's go and get this x to the other side, because we want to get y by itself, alone, right? Okay, so minus x. So what do I have left? Negative 2y equals negative x plus 8. We could put 8 minus x, but we usually see the x first, right? So I'm going to put negative x plus 8. Good. So we just move the x over. Got that out of the way. Now let's get this out of the way. How do we get rid of the negative 2? Divide it. So I divide by negative 2 on this side, and whatever I do this side, I got to do this side. How do I divide this? I got to divide the entire side by negative 2. The entire side. So I just make sure I divide everything by negative 2. So I'll go ahead and put it there. And also the 8 divided by negative 2. Let's divide everything by negative 2. Okay? So now let's rewrite what we have. So we have positive 1y is equal to, how do we want to write that? Negative 1 over, negative 1 divided by negative, negative divided by negative. It's a positive. So negative 1, so it's positive 1/2, and I'm going to write it like that, 1/2 x. Right, isn't that positive 1/2 x? Right? And then, ooh, what's this? Minus 4. You can put plus negative 4. Plus negative 4. Well, it's just minus 4. That's our line that we're going to graph. So we had to get it to this point. Now we can sketch this pretty easily, just like we did yesterday. Shift. Shift. Does this go left or right? No. Okay, there's no parenthesis there like we're used to seeing. But it does go down 4. So nothing left or right. Down 4. So 1, 2, 3, 4. Nothing left or right. Down 4. There we go. Okay, now just do the slope. Do the slope. It's a line. So up 1 over 2. There we go. And got it. They may ask for domain and range, but it's domain's all real numbers, range is all real heights, all real numbers there too. All right. So we're good. Okay, composite functions, we know what that is now. F of g of x. Just follow your notes if you forgot. Okay, your assignment is actually in the original packet that we got, worksheet 2. So worksheet number 2. Okay, the whole thing, I think it's on front and back, I'm not sure, but it's your original packet, it's worksheet number 2. Okay, it's got some review on the front and then composite stuff on the back. Okay. That's a wrap.